Okay, good morning class. Okay, we have started with our paper 2, correct? Here we got to question 3 or 4. We got to question 5. Okay, so we're on question 6 now. Now we haven't completed 5. We started with 5 and didn't complete. Okay. So let's go through it again. So we have two graphs. You got f, which is 3 cos x, and g, which is sin x. The first question was probably to calculate p. Yes, it did. So we got the values of a and b. Okay, so a was 3 and b was 1. Okay. Then the question was determine the value of p. And since p was on the coordinate of a, which is 71 and 6, and p, so what I did was I put 71.6 into the f of x graph, so it's going to be 3 cos 71.6. That will be 0.94. Or if you had substituted into the other one, which is sine 71.6, gives you 0.9495. Okay. So I think I will do 0.94. No? The coordinates of b. Now if you look at b, see that distance from 92 to point A is the same distance from 90 to point B. Can you see that? So to get b's coordinate, we're going to say it's what's 90 minus 71.6 gives an answer of 18.4. So that distance is 18.4. The 270 minus 18.4 gives an answer of 251.6. 251.6 degrees. Now, of course, the corresponding y value is also 0.98, but in the negative direction, so negative 0.98. No, sorry, 94. Okay, you can test it. Say 3 cos of 251.6. Okay, as you can see, it's negative 0.95. It's actually 95 in both cases. Okay. Is there any confusion there? Let's go to the next question. Now we are asked to write down the range. So if you're looking at the range of h, if h of x is equal to g of x plus 1, so what is the current range of g of x? What is the range of g of x? So if you're looking at g of x range is going to from 1 to negative 1. So the range of g of x is y is greater than or equal to negative 1 but less than 1. That's the range. So if you're looking at plus 1, what effect does that plus 1 have on the graph? So to shift the graph 1 unit up. So from negative 1 it goes to 0, of course. So y is greater than or equal to 0. And from 1 it goes to 2, but less than or equal to 2. Okay, in question 5.5, we have to write down the domain of j of x equal to f of 4 of x. So what is the range, the domain of f of x? So if I look at the f graph, the cos graph. So what is the domain of this graph? It's supposed to be the domain. So the domain is from 0 to 360. Even if you're going to divide this by 4, okay, but the given domain is from 0 to 360. Okay, domain is all possible x values. So if this graph was not from 0 to 360, then the domain of this graph is from negative infinity to positive infinity, which means to say it's all real values of x. You guys understand? What is domain? All possible x values. The question that I meant to have asked here was write down the period. It's supposed to have been period. I'm not sure if I corrected it. I sent the message to the classes that was writing in that year. I can't remember. But then it should have been the period of the graph. So it doesn't make sense to have asked for the domain. So the domain is from 0 to 360. Even if this gets 4 cycles from 0 to 360, it is still 0 to 360. You guys understand? But if you ask for the period of this f of x graph is 360 of the f of x graph. But since there's a 4 in front, I divide this by 4. So the period of the graph is 90. Okay? 90 degrees there. What did I write in the memo? Yeah, and I probably sent that message. Or if I picked it up while I was marking, I would have awarded the kids the mark for it. But I should have written it in the memo. Yeah, it's a mistake, okay? But did I pick it up? Sorry for those. In that case, in that year. Okay? Because then let's say calculate the length of CD, correct one decimal place. Given that CD is parallel to the y-axis and the y-coordinate of C is 2p. Okay, let's say they want to know this distance here. Okay. Okay, so the y-coordinate of C. So it's x and some y value, but that is 2p. The C value is the y value is 2p. So of course, I can work out this y value here. Okay, so I can say I can only use the f of x graph, so that's on f of x. So 3 cos x is equal to 2p. And what is p in this case? P is 0.95. Can you see that? So it's twice the 2 times 0.95. Okay, so what do now is I divide by 3 and I take arc cos in this case. So that's my reference angle. Okay, so we say shift cos of 2 times 0.95 divided by 3. So that gives you 50.7. Okay? 50.7 degrees. But as you can see, this cos is positive. At which point is cos positive? Quadrant 1 and 4. But we could it then be, is that point C between 0 and 90? Which is quadrant 1? No. It's actually between 270 and 360. Can you see that, people? So it's actually in quadrant 51.2. But remember, I got 94 earlier on here. Yeah, 51.2. Okay. So, where was that? It could either be in quadrant 1 or quadrant 4. No? Then as you can see, C is definitely between 270 and 360 degrees. You guys see that? So my X value is then actually 360 minus 50.7. So 360 minus 50.7 is 309, 3. Comma 3 degrees. But have I answered the question? No. The question was for CD. So CD, to work a distance out between two graphs, I take the top graph, which is the f of x graph. So f of 309.3 minus the g of x graph, which is g of x, which is sine of x, which is 309.3. Okay. So we're going to say 3 cos 309.3 minus g, which is sine 309.3. Okay, I don't need this line here. I could have gone straight into this if needed. So it's going to be 3 cos, that answer, minus sine, that same answer. Gives you a distance of 2.67. Okay. So a nice question for 5 marks. Any confusion here? Any questions? No? Right, so that brings us now to our favorite, geometry. No? Yes, okay. That don't sound too convinced. Convincing. Convinced. Alright, so here we are told that in a diagram alongside, PT is the diameter. People, if PT is the diameter, what do we know? Many things. Huh? But among the things we know that this angle here is going to be 90 degrees. Why? Angle in the semicircle. Okay. Then we are told that with center O, people, if this is center, what do we know? Angle at center twice angle at circumference. We also know those lengths are equal. Okay? Isosceles triangles and all of those things being formed there as well. Okay, there's no isosceles, but those lengths are equal. Okay? We were told that M and S are points on the circle on either side of PT. Then we were told that MPTS, MP, NT, MS and OS are drawn. M2 is 37 degrees. Calculate with the reason the size of M1. Okay, so we already indicated that that's going to be 90 degrees, not so. So angle M1 is going to be 90 minus 37. Why? Angle in semicircle. And 90 minus 37 is 53 degrees. So put 53 degrees there. Then this is O1. We already said that O1, angle O1 is going to be double M1. So O1 is equal to 2 times 53. Why? Angle at center is equal to 2 times angle at circumference. Okay. Give you an answer, 106 degrees. Okay. Any confusion there? Alright, let's go to the next question. 6.2. So in 6.2, we are told that in the diagram, O is the center of the circle. People, if O is the center of the circle, what do we know? The angle at center is twice angle at circumference. So this angle is double that angle. Okay? Can I say that 106 plus T1 equals 180? Opposite angles of a cyclic what? No, why not? This point is not touching the circumference of the circle. For cyclic quad, all 4 points must touch the circumference of the circle. Okay. So we are told that. Right. Let's carry on reading. Also, that's the center. We know those lengths are equal. Okay. Radial in that case, if needed. Then we are told that MK and LM are tangents to the circle. People, this is a tangent, what we know? This is going to be 90 and that's 90. Why? Why are those two angles 90? Radius, perpendicular to tangent, yes. So if those angles are 90 and 90, what do we know about this quad? It's a cyclic quad. Why? Opposite angles are equal in this quad. Opposite angles are supplementary. Okay, well done. Also, if these are two tangents, what else do we know? We know that that length is equal to that length. Km is equal to ML. Why? Tangents from external point to common point. Okay. A tangent to the circle at K and L respectively. T is the point on circumference of the circle. KT and LT are joined. O1 is 106. Question says calculate the size of T1. We spoke about that already. No? There's a relationship between O2 and T1. So where do we start? We start by working out O2. So O2 is equal to what? 360 minus 106. Why? It's a revolution. Okay? And that will give an answer of 254 degrees. 254. So T1 is going to be, of course, half of that. Why? Angle at center is equal to 2 times angle at circumference. We give an answer of 127, 127 degrees. Okay, any confusion there? No. Next question. Since if we calculated this already on the diagram now, it says prove that OKLM, OML is a kite. There are 5 properties of a kite. What are the 5 properties? If this is a kite, what are the properties? 2 pairs of adjacent sides equal. Is that evident in any other figure other than the square? But then all sides are equal in the square. But is that evident anywhere else? No. So that would have been suffice for us to prove this is a kite. The least it would be it's a kite. Okay? You have another property of a kite? Yes? 1 pair of opposite angles are equal. Is that in any other, that the least it can be would be a kite again? Another one? The third one? To do with the diagonals. Sorry? Diagonals bisect at 90 degrees. The diagonals cut each other at 90 degrees. Yes, what else? Fourth one? Come guys, you can't done this in grade 9. One diagonal bisect the other. One more. One diagonal bisect its vertex angles. Okay, all of those are evident in a kite. Okay, so to prove this is a kite, What did we say earlier on? We know that that length is equal to that length. Not so. And we know this length is equal to this length. So there we have a kite already. Not so? That first property that we had. So how do we lay that out? We firstly say that Km is equal to Lm. Why? Tangents from common point. Tangents from common point, which is M in this case, or external point. Then we know that OK is equal to OL. Why? Potential radius. So now we say, since this is the case, therefore KMLO is a kite. Why? Because two pairs of adjacent sides equal in kite. Two pairs of adjacent sides are equal in that kite. Okay. So now with that, all that properties that we had, that we drew here, is now evident in this diagram. Okay. If I draw diagonals, then I can bring all the other four properties into this kite here. Okay. So at this point we have proven it. Also, if you didn't manage to prove the kite here, in the next question, if needed, we can use the reason or the properties of the kite to answer the next question if needed. Okay. Next question. So here we are now told that in number 3, prove that quadrilateral KLMN OKLM is a cyclic quadrilateral. So how do we prove this is cyclic? We said it earlier on. We'll go with the fact that those two angles are 90. The sum of it is equal to 180, so it's a cyclic quad. Okay. Or I can go with the fact that that is 90. The exterior angle is equal to the interior opposite. Okay, whichever way suits you. But you see, there's no letter here. I don't know how you're gonna label that later. Or you're gonna name that angle. Otherwise, you can say you can put your own letter in on the diagram sheet. Okay, so that the examiner knows what you did. Okay. So firstly, OK, M is equal to 90. Why? Radius perpendicular to tangent. Then OLM is 90. Radius perpendicular to tangent. Okay. So now we state the obvious. We say since, of our observation, since OKM plus OLM is equal to 90 plus 90, which is 180. Therefore, OKML is a cyclic quad. Why? Because opposite angles are supplementary. Opposite angles are supplementary. Okay? Which means just the opposite angles adds up to 180. Okay. Otherwise, you could have said the converse of opposite angles of a cyclic quad. But remember, if they ask you to prove it's a cyclic quad, you don't use cyclic quad in here, in your final reason, unless you say converse. Okay. Otherwise, do not use cyclic quad here. Otherwise, you will lose that that mark there. Okay. So this is now a cyclic quad to us. Okay. Let's go with the last question. The last question is calculate with the reason the size of angle M. So I need the space here. Calculate with the reason the size of angle M. So if you look at where M is here, not so. But remember, this is a cyclic quad. What does it mean if it's cyclic? That means to say a circle can be drawn around here. Okay, that's basically what it means. So if that is cyclic, we know that opposite angles are supplementary. So angle M is equal to 180 minus 106. Why? Opposite angles of cyclic quad. Okay, so that's going to give you an answer of 70. Otherwise, you could have said 106 plus 90 plus angle M plus 90 is equal to 360. Why? Because it's the interior angles of a, not cyclic quad, but it's a quadrilateral. You could have said cyclic quad as well. The interior angles of a cat. Okay. Let's go to the next one. We are told, this is the last question. Yep. But we are sure we have enough time. So we are told that in the diagram, M is the center of the circle. So if M is the center of the circle, then this length here is equal to that length there. Okay. Why? Because if that's the center, then that's your radius. Not so. Which is also equal to the. So those angles are equal. Angles opposite equal sides. You see, this is marked 1 here. Two strokes there. So this angle, that length, this length, that length, and this length are equal. Can you see that? So all of these are equal. That's also 20 degrees there. Okay? Then we are told that the circle passes through L, M, P. PM is produced to K. K, L, M, N is a cyclic one. K, L, M, N. So if there's a cyclic one, opposite angles are supplementary. So that angle plus that angle is also 180. Okay, that's the relationship. Because that is now a cyclic one. Okay. Then we are told the larger circle having KL equal to, right? So we already spoke about that thing. LP join, KML is 20 degrees. Okay. So with all that in mind, let's just take this off here. As you can see, the diagram is very busy. The question says write down with reason the size of NKM. NKM. In K M. So this angle here. The 2 marks. See any lines at the parallel, they know. Sorry about that. In KM. Oh, you see here, that is equal to this here, not so. So which means to say that angle is equal to this angle. As you can see here, that is coming from one of the corollaries of angles in the same segment. This one is used very seldom. Okay, so you tend to forget. So that length, this must touch there, no? And if those are equal, then P is equal to angle P is equal to angle Q. Why? Equal angles. Equal sides. Equal lengths, subtends equal angles on the same side. Okay. Equal lengths, subtends equal angles on the same side. So that is 20 degrees. So you say K1 is equal to 20 degrees. Equal chords. Subtend equal angles on the same side. Okay. So with that now, what do we know? These lines are parallel if needed. Can you see that? Why? Because the alternate angles are. Since the alternate angles are equal, those lines will definitely be parallel. Okay. Well, the other asked you that exactly that question. Let's look at number 2. Give a reason why KL is parallel. Give a reason why KL is parallel to LM. KN is parallel to LM. I just told you now, since M1 is equal to K1, which is equal to 20. Okay. Therefore, LM is parallel to KN. KN. Why? Because alternate angles are equal. Can't just say alternate angles. We say alternate angles are equal. So now we add that to the diagram. Again, people, if you didn't know how to do that, you just add it to the diagram because you probably need it later on in the sum as well. Okay. Number 3 says, prove that KL, so here's KL, is marked 2, is equal to LM. Okay, LM, which is this length here. But I showed you earlier on it is equal, okay. So firstly, we know that KL is equal to MN, that was given to us. Okay, but MN is equal to, so with 2 markings there, is equal to PM and ML. Okay, I don't need to say PM, but I'll just pick it up one time, otherwise I would need to say it later again. Okay, so KL is equal to PM, as I said, this one is not needed at this point, equals LM. Why? So it's all radii there. Okay, so therefore KL has to be, if KL is equal to MN and MN is equal to LM, therefore LK is equal to LM. Okay. Any questions there? No? 7.4.1. So here we are told, let's put that down a bit, let's put that up. Okay, so in the next question we are told, calculate with the reason the size of KNM. To the side of this angle here. Okay, so we said earlier on that this of course is a cyclic point. Not so? So we know that K2 we can calculate, we know it's 280, angles opposite equal sides. We got that one, so we then, that would be the unknown angle, which is M2. Okay, so just lay that out quickly, properly. Lay this off. So firstly, we're going to say that in 7.4.1, this is going to be 280 degrees. So K2 is 280 degrees. Why? Angles opposite equal sides. Okay. You all okay with that? So now we're saying that this angle here, which is 40 degrees, or 20 plus 20, plus M2, plus that 20 degrees, okay, equals 180. Why? Opposite angles of cyclic coil. Did I say earlier on they were equal? Oh, okay. Opposite angles of a cyclic coil. And of course M2 is equal to, that gives you an answer of 60 degrees. So 180 minus 60 is 120. So M2 is 120 degrees. Is that correct? Okay. And then in the third case, they want to know, in the last question, they want to know the size of LPN. LPN. This is whole angle here. Okay. Sorry? Sorry? Okay, let's go. So this is the problem here. Huh? Okay. K in M. K in M. I calculated the wrong angle. No, why is it right? Okay, so I have to go further. So this is the angle in question. Oops. This is the angle in question. So here I can just go sum of triangles. No? So N1 is equal to 180 minus 120 minus 20. Why? Sum of triangles, and this triangle KMN, which is 40 degrees. Okay. Thank you, Michael. Now the question says calculate LPN. LPN. So we know that this is going to be exterior angle of triangles equal to the interior opposite, sum of the interior opposite, while Z are equal as well. So that's 60 and 60. Not so. Then, you see here, exterior angle again is equal to the sum of the two interior opposite. But those angles, those lengths are also equal. So the size of this angle in question is actually 70 degrees. Okay? You guys understand? So let's just lay it out quickly. Let's use the other color there. There's probably an easier way. Yeah, definitely an easier way. Because I'm seeing it's only 3 marks. So I realized that there must be an easier way. But what I notice is that this arc LN is actually subtending this angle here. So the angle at center is twice the angle at circumference. Can you see that, people? So in other words, NPL so LPN is equal to this angle here is 140. So it's going to be half of 140. Why? Angle at center is equal to 2 times angle at circumference. That will give you an angle of 70 degrees. Okay, so much easier. Okay, give you an angle of 70 degrees. This is a good question. I'm sure you guys are going to say, oh, the questions are good. Okay, the proof to this theorem will be found in the description box below. It's about 6 or 7 marks normally. I'm sure this is the last question. Okay. In this paper, I gave 2 circles, 2 questions with double circles. Normally we just give one. For some reason or other, this year I gave two. We are told that in the diagram, PQ is a tangent to the circle QST at Q. People say this is a tangent, then Q1 has to be equal to T, tan equals Q. Alright, then we are told that QT is a chord of the circle and TS produced meets the tangent at P. Then we are told that R is a point on QT such that PQRS is a cyclic quad. PQRS. So this is a cyclic quad. We know that Q1 is actually equal to R2. Why? Angles in the same segment. But what do you notice now? That I can actually draw a circle around here. Why? Because of the converse of the tan chord theorem. Can't you see that? Huh? Hello? Alright, you guys got it? I'm talking to myself here. No? It's going to be a long year next year. Yo. PQR is a cyclic quad in another circle. We tell that PRQ is and RS are joined. Question says, let's just take this up here. Let's just take this out. First question. Give a reason for each statement. Write down only the reason next to the question number. Okay, so let's see. They only want you to write down the reason. Okay, so it's 1 mark each there. The question says, why is Q1 equal to angle T? Why is Q1 equal to T? We said that already. Why? Tan chord theorem. Okay, you all agree with that? Then why is Q2 equal to P2? What you notice is that I'm not going with an arc again. Why? Because they are different angles. Can you see that, people? So why is Q2 equal to angle P? Because it's angled in same segment. And it's coming from arc. So denoted by arc. RS. Do you have to mention the arc? No. Okay. Next question. In 8.2.2 they ask you to prove that PQR is an isosceles triangle. PQR is an isosceles triangle. Okay, so when is something isosceles? Either two angles are equal or two sides are equal. Okay. So if you look at this here, you see this angles are already marked here. But this angle here can get the same marking. Why? Because this R1 is actually equal to angle T plus P2. Can you see that, people? Why? Why is that the case? Anybody? You don't have to put up your hand. Exterior angle of triangle is equal to the sum of the two interior opposites. Okay. So 8.2.2. Since R1 is equal to P2 plus angle T. Exterior angle of triangle. And the exterior angle of triangle P is R. Okay. So since, stating the obvious, R1, angle R1 is now equal to PQR. Therefore, triangle PQR is an isosceles triangle. Why? Why did I ask this? Because it is base angles are equal. Okay. Base angles of the triangle is equal. Which now means to say that those lengths are also equal if needed. Okay. Verstaan julle? Yeah, okay. Last question. Here we are told that prove that PR is a tangent to the circle. PR is a tangent to the circle R is T. People, we spoke about that already. Not so? We're going to use the converse of the tan chord theorem. Okay. Again, I'm going to take this off here, and everything that's written is already on the diagram. Okay. So we just need to prove that T2, angle T is equal to R2. Not so. But we know that Q1 is equal to R2. Why? Angles in same segment. And it's coming from arc. This angle here is subtended by arc, PS. Again, the arc doesn't need to be stated, okay? So what do you notice now? It has the same marking. One arc, no? So you say the obvious. Since angle R2 is equal to angle T. That's our observation. Now fine. Therefore, PR is a tangent to circle through SRT. RST. Why? Because of angle between line and chord equals the angle in the alternate segment. Okay, or you could have just written the converse of tan chord theorem, the reverse of the tan chord theorem. And that basically brings us to the end of this paper. Okay? Now you find the paper? How was it? Easy. Okay, nice. Right, so we're going to choose another paper now for our next lesson. Alright. That's great.